Welcoming you all, my dear student. This class I am going to discuss with you about ferrous sulphate. That is the what is the preparation and properties, uses and assay about ferrous sulphate. In previous session, we discussing about introduction part of emetanic. So the here this ferrous sulphate, the combination of ferrous sulphate and folic acid majorly used for the treatment of iron deficiency of anemia. So now this class will see about how they are preparing ferrous sulphate and what is the properties, uses and assay of ferrous sulphate. So what is the molecular formula for ferrous sulphate? FeSO4, 7 molecules of water. So next we'll see it is having not less than 98%, not more than 103.3 N of FeSO4, 7 molecules of water. So how do they prepare ferrous sulphate? So preparation of ferrous sulphate, first that ferrous in the form of ferrous is nothing but iron. So iron in excess of dilute sulfuric acid, after the effervescence ceases, the liquid is filtered, concentrated and cooled. First the iron first treated with the dilute sulfuric acid. After the effervescence will comes out, that means after the effervescence ceases, the liquid is filtered, concentrated and cooled. The green crystals of uh, are separated by filtration at room temperature. In all these operations, undue exposure to air is prevented because ferrous sulphate is oxidized readily on exposure to moist air and the crystals get coated with brownish yellow ferric sulphate. Okay, so how they are preparing, first we'll see the chemical equation. Ferrous, that means iron to be treated with sulfuric acid, so it is the formation of ferrous sulphate and hydrogen ceases. After the effervescence ceases, then immediately going to get concentrated and that cooled and also filtered at room temperature. So this overall preparation done by without exposing to the air, because it is readily oxidized on exposure to moist air and the crystals get coated with brownish yellow ferric sulphate. So because in order to prevent this conversion of ferrous to ferric, so in order to conversion of ferrous to ferric sulphate, so the whole preparation should be operated under exposure, without exposure, or the exposure to air is prevented. So this is the mechanism. Once again let me repeat the chemical reaction or preparation of ferrous sulphate. Ferrous with sulfuric acid, so the formation of FeSO4 plus hydrogen. So this is the method of preparation of ferrous sulphate. Next we'll see about properties. I told you in that before also, the color of ferrous sulphate, always remember that it occurs in the form of greenish crystals. So if ferrous sulphate means greenish crystal and copper sulphate become bluish. Okay, so this is the difference why ferrous sulphate become green and copper sulphate, that also hydrous form of copper sulphate become blue color and anhydrous form of ferrous copper sulphate colorless. So that also you should remember that. Here now we'll see about ferrous sulphate. So what is the properties of ferrous sulphate? It occurs in the form of greenish crystals, crystalline powder or greenish crystals or crystalline powder, having an astringent taste it effervescence in dry air. I already told you. So in order to prevent the ferrous to ferric form, so it is easily to effervescence in dry air. When exposed to air, that what we discussed before, when exposed to air, it get oxidized to ferric salt. That means in order to prevent the ferrous to ferric, that means if the ferrous form of sulphate on exposure to air, so it is converted into ferric form. So what is the formula for ferrous? Fe2 plus. Okay, so Fe2 plus converting into Fe3 plus. Okay, now when exposed to air, it gets oxidized to ferric salt, which is having a brownish yellow color. So remember that when in ferrous form of ferrous form means that has greenish color. If when it is converted into ferric form, so that will give you change the color, change it into brownish yellow color. So this is Fe2 plus become greenish crystal, and Fe3 plus, while on exposure to air, this ferrous sulphate converting to ferric sulphate. So this greenish crystals on exposure to air, it is converting into the color changes into greenish to brownish yellow color. Okay, so I think you all are understood. So it is soluble in water but insoluble in alcohol. It is soluble in water but insoluble in alcohol. Next, ferrous sulphate when heated decomposes to yield ferric oxide. One more thing, while on heating ferrous sulphate, it is converted into ferric oxide, sulfur dioxide. What is that? Ferric oxide, sulfur dioxide. This is the molecular formula for sulfur dioxide and sulfuric acid. Okay. So next, overall, let's once again let me repeat the same. What are all the properties of ferrous sulphate? Ferrous sulphate, first in the ferrous form, what is the color? Greenish crystal. On exposed on air, so it is converting into brownish yellow color. So this is Fe2 plus ferrous form and Fe3 plus. Then this is the first. Next one, depends upon the solubility. It is soluble in, depends upon the solubility, it is freely soluble in water and insoluble in alcohol. And taste depends upon the taste. Let's see the taste. This is astringent taste. Next, when heated, that means on heated, it is converting into, so on heating, so the reaction like becomes ferrous sulphate to ferric oxide and sulfur dioxide and sulfuric acid. So on heating, ferrous sulphate on heating, it is converted into ferric oxide, sulfur dioxide and sulfuric acid. Okay, so these are the property. Next, ferrous sulphate on reduces, on heating it is going to oxidize, but on reduces the salt of silver and gold to their corresponding metal with some alkali sulphate, it forms double salt. So on reduces with, like in form of Fe2 plus, on that means ferrous sulphate, when on heating with some other metals like Ag, silver. What is the formula for silver? Ag plus. And what is the formula for gold? Au. Okay, so it gives double salt. Nothing but when silver react with ferrous sulphate, so silver Ag plus and Fe3 plus. Here the ferrous form converting into ferric form, so it forms double salt, that is known as double salt. So here that like the same as that when gold when silver react with ferrous, converting into silver Ag plus and Fe3 plus, as well as when gold react with ferrous, so it is converting into Au plus and A3Fe3 plus. So these are double sided. It forms on reduces with salt. So these are the reducing agent like Ag silver plus and Au, that means gold and silver on reduces with the iron, so it gives the double salt. Okay, next, in presence of light. So what will occur when in presence of light, the ferrous sulphate reduces mercury chloride to mercurous. So in presence of light, so let us assume that, so in presence of light, so when iron, when treated with mercuric to mercurous, okay, mercury HgCl2, so this is the mercuric. What is the molecular formula? HgCl2 is nothing but mercuric chloride, and it is converting to mercurous chloride. What is the formula? Mercurous chloride, Hg2Cl2. So mercury, that is the difference. Here there is no 2. This is mercuric and this is mercurous. What is the formula? Once again, mercuric HgCl2, mercurous Hg2Cl2. So on light or in presence of light. So first, on exposure to air, it is converting to ferrous to ferric oxide, with reducing with some metal like silver and gold, it gives the double salt. And next, in presence of light, it is mercuric and treated with iron, treated with mercury chloride, mercuric to mercurous chloride. Okay, so next, when ferrous sulphate react with sodium carbonate, carbon dioxide. So from sodium carbonate, there is carbonate is there is a removal of carbon dioxide from sodium carbonate. So when ferrous sulphate react with sodium carbonate, what is that? Ferrous FeSO4, when react with sodium carbonate, so ferric carbonate FeCO3 plus sulphate. And next one, when ferric carbonate on hydrolysis, so ferric hydroxide and releasing carbon dioxide. So this is the overall reaction with when ferrous sulphate reacts with sodium carbonate. It is very easy to understand all those reactions. Let me revise once again what are all the properties. So first, and we'll see the color become, if it is in case of ferrous form, so it is become green color. In case of exposure to air, this ferrous converting into ferric, that time the color become brownish yellow color. Okay, then the taste wise, it is become an astringent taste. And next, solubility, so it is soluble in water but insoluble in alcohol. Next, unheated with ferrous sulphate, so it gives ferric oxide. On heating, what will happen? And when in presence of light, what will happen? And what when it is treating with the reducing agent like silver and gold, so on heating with ferrous sulphate, conversion of ferric oxide and sulfur dioxide and sulfuric acid and water molecule. Next, on reducing with that silver and gold, so it is converting into double salt. Okay, ferrous to ferric form, there is a formation of double salt. And in presence of light, the mercury chloride converting into mercurous chloride, HgCl2 into Hg2Cl2, that is the difference. This is mercuric, this is mercurous. Okay, next, when treated with sodium carbonate, there is the releasing of carbon dioxide. So first converting into FeCO3, thereafter it is on hydrolysis, so it is converting of ferric hydroxide plus carbon dioxide, that means releasing carbon dioxide. Next we'll see about test for identity. What is it yields reaction which are characteristic of iron and sulphate. We'll see test for identity which with by test for purity. It has to be tested for. So what are all the tests to be identify whether the ferrous sulphate become pure or impure. So we have to conduct arsenic, copper, heavy metals and basic sulphate. That means 1 gram in 2 ml of freshly boiled water shows only faint turbidity. So it has to be tested for acidity, whether if it is acidic nature or acidity. These are the tests to be conducted. Next, acidity. How do you perform the acidity? It can be determined by measurement of pH or by treating with standard alkali. So by measuring with their pH, so you know all are the pH level of acidic and alkali and neutral. Okay, so if it is below or above means what is the range? You know, pH 7.4 is the neutral. That is what is the pH range of blood, the same 7.4, and if it is less or above or below, that to be determined whether it is acidic or alkali. Okay, so if below the 7 it is known as acidic and above means alkali. So the solution of 5 gram in 50 ml of, so depends upon the measurement of pH by or by, there is the two way to find out the acidic nature of the ferrous sulphate. So by treating with measurement with the pH paper or pH measurement of pH, or by treating with the standard alkali. Next, for that a solution of 5 gram in 50 ml of water requires not more than 1 ml of 0.1 N sodium hydroxide using solution methyl orange as an indicator. So that ferrous sulphate to be first dissolved in water, 50 ml of water. Thereafter it is to be titrated with N by 10 sodium hydroxide using methyl orange as an indicator. So by titrating with that, so we can find out the acidity of the test ferrous sulphate. So next one, arsenic. So it should not be more than 2 parts per million. So they are given the limits of arsenic to be present in ferrous sulphate within the range of 2 ppm, that means 2 parts per million. Next, copper. Then how could be able to test with the copper present with the ferrous sulphate or not? So it may be test by dissolving 2 gram of ferrous sulphate, the same which you have already taken for acidity, that means titration. So the same 2 gram to be dissolved to either 2 gram, not specified quantity, either small quantity of the sample also to be dissolved in water by acidifying with the 1 ml of dilute sulfuric acid. So this is the overall method of, that means iron to be treated with sulfuric acid. So we will form, what is that? Ferrous sulphate. So first acidified with sulfuric acid, then the solution is saturated with hydrogen sulfide. So no darkening of the solution of precipitation should occur. So it indicates that there is no copper present in the sample. That means the color, no darkening of the solution, which indicates you there is no impure with the copper. Okay, next, basic sulfate. How do you perform the basic sulfate test for insoluble sulfate? So these may be detected by the presence of turbidity in the aqueous solution. Aqueous solution is nothing but the solution first to be treated with the water, that is known as aqueous solution. So recently boiled and cooled water is used in test, otherwise the turbidity might appear due to oxidation of Fe2 plus by the dissolving oxygen in the air. I already told you. So if it is care must be taken to find out the acidity, basic sulfate present or are absent in the ferrous sulfate. So this must be taken very seriously. So first it is to be aqueous solution to be treated with in order to find out the turbidity. So if in case the recently boiled and cooled water is used, that means free from carbon dioxide in oxygen. Why? Because why we are here, we are using boiled and cold water means, so in that normal water, that oxygen and carbon dioxide to be mixed with that. So while we are going to boil the water, so that oxygen and carbon dioxide will escape from the water, then let the water to be cooled. So this boiled and cold water to be used for the to identify the basic sulfate immediately. Otherwise, if we didn't do that within the time, so what will happen? So this turbidity, so here we are going to compare the or observing the turbidity. The turbidity indicates that there is insoluble sulfate. So if we are taking normal water, does it allow you to show the turbidity? So the boiled and cooled water to be taken to observe the turbidity, that means insoluble sulfate. So suppose if normal water means, so already it is oxygen is there, that ferrous sulfate, the nature of ferrous sulfate, when it exposure with the oxygen, it is converting into ferric oxide, ferric Fe3 plus. So by due to oxidation of Fe2 plus, so by the dissolving oxygen in water. So I think you may able to understand that what is the reason to use boiled and cold water immediately treating with the ferrous sulfate, so that the turbidity, insoluble sulfates of turbidity can absorb in with the comparison with the turbidity. Otherwise it might be converting ferric form in the normal water contain oxygen. So immediately that Fe2 plus converting into ferric form. So in order to prevent that, so we have to use boiled and cold water. Okay, next we'll see assay. Then how do you perform the assay for the ferrous sulfate? So here it is assayed by oxidation reduction type. So once again listen. So what is the type of ferrous sulfate? Oxidation reduction. It's a very important one. You may perform in the analysis subject also, pharmaceutical analysis. So there also you will do the same assay method. So what is the type of ferrous sulfate assay method means? Oxidation reduction type of reaction using. So whenever you will have that wherever you will have oxidation reduction type, so there is a titrant become N/10 potassium permanganate solution in presence of sulfuric acid. Here there is no indicator, that potassium permanganate act as a self indicator. So then now we'll see how we'll perform the assay of oxidation reduction type of ferrous sulfate. That means ferrous sulfate with potassium permanganate in presence of sulfuric acid. So an accurately weighed about 1 gram is dissolved in accurately weighed 1 gram dissolved in 20 ml of dilute sulfuric acid. How much? First 1 gram of ferrous sulphate dissolved in 20 ml. How much? 20 ml of dilute sulfuric acid. Then it is titrated with, what is the titrant in the beaker? You have to fill the KMNO4. What is the strength? N by 10. N by 10 nothing but 0.1 N potassium permanganate. Here in the conical flask we are going to take in the 1 gram of your ferrous sulphate dissolved in 20 ml of sulfuric acid. Then it is to be treated. So here what is the chemical reaction going on? So this is the overall reaction of when ferrous sulphate treated with potassium permanganate in presence of sulfuric acid, means there is the formation of three type of sulphate like Fe2SO4 thrice and MnSO4 and K2SO4 and water molecule. Okay, so the each ml of N by 10 potassium permanganate is equivalent to this is the molecular weight of ferrous sulphate. So in the beginning class also I told you. So what is the molecular formula for ferrous sulphate? 278.0, or so that means the 1000 ml to be taken dissolving with the 0.0291 gram of ferrous FeSO4, 7 molecules of water. So now let's see. Now it is assayed by taking about 1 gram accurately weighed sample and dissolved in about 3 ml of water and 20 ml of sulfuric acid in conical flask. So now let's see here. This is one more method also can be done. So I think here they written in wrong. Here we should have 0.0 here always, that is equivalent to, so you have to divide by the 1000 ml, so 0.0298. so this is one method, and another method also we can perform with that steric ammonium. Here you may notice that that is equivalent to this has to be come for the previous one more method with ferrous sulphate. Now we discuss ferrous sulphate with dilute sulfuric acid in presence of dilute sulfuric acid and titrated with, that is oxidation reduction method, and one more method with steric ammonium sulphate. Then how do they perform? Now also 1 gram accurately weighed sample and dissolved in about 30 ml of water and 20 ml of dilute sulfuric acid in the conical flask. Finally titrated with standard, what is that, 0.1 m steric ammonium nitrate. What is the steric ammonium nitrate? Okay, taken in burette using steric ammonium nitrate using ferrion sulphate solution as an indicator. So nothing but there are two methods of assay. What are the two methods of assay? Here oxidation reduction. What is the oxidation? Two method, oxidation reduction method here with steric ammonium nitrate and using ferrion as an indicator here. Here the burette to be filled with steric ammonium nitrate. This method to be filled with a potassium permanganate. Here there is no indicator, but here we have ferrion as an indicator. But overall in the conical flask we will have the same 1 gram of specific quantity to be dissolved in sulfuric acid. Here also the sample to be dissolved in sulfuric acid. Here we are going to treat with steric ammonium. Here we are going to treat with potassium permanganate. So this is a two type of method of preparation. So this method of assay, we have the chemical equation, ferrous sulphate and ferric sulphate, ferric ammonium sulphate, sorry, here also the ferric ammonium sulphate or nitrate, here they mention ferric ammonium nitrate, but the formula becomes ferric ammonium sulphate. So thereby formation of ferrous sulphate, ferric ammonium sulphate CaS, and next ferrous sulphate and ferrous sulphate and manganese sulphate and removal of ammonium to dihydroxy sulphate. So these are the chemical equation of another method with the ferric ammonium sulphate with ferrion as an indicator. Okay, now finally we'll see about uses of ferrous sulphate. Finds use as a hematonic, that is for preparing or promoting formation of hemoglobin. So overall, what are the excessive use or consumed mistakenly by children may cause GIT irritation. What will occur? So suppose in case of excessive intake of ferrous sulphate which leads to GIT disturbances, so orally it is administered in the form of, what are all the type of formulation available, either tablet or capsule, and oral preparation including liquids are marketed. And in order to stabilize the ferrous form, I told you, so it is immediately on exposure. Suppose if you are storing on sunlight, so it is immediately converting ferrous to ferric. Certain reducer agents such as hypophosphorus acid and dextrose are included. So so in order to prevent the ferrous to ferric form, here they are going to adding phosphorus acid and dextrose are included in such formulation. Then ferrous sulphate solution may bring about discoloration of teeth in contract. So after taking while in form of oral syrup, and what will occur, so that the stains will appear on our teeth because of that having nature of discoloration of the teeth while we are using ferrous sulphate. Then next one, dose, it should be this is the storage, not dose become to be taken orally or in tablet or capsule form. In the market also you may observe that the ferrous sulphate and folic acid and sulphate combination are available in order to treat the deficiency of anemia. Okay, so I think overall you may understood that what are all the ferrous sulphate details about how do they prepare ferrous sulphate, and what are all the properties, and test for purity, test for identity here we carried out. That means test for identity, arsenic, copper, there is the limitation not more than 2 ppm for arsenic, and insoluble sulphate. And next one, test for acidity we perform, and copper. So these are the major tests for identity. And assay, there are two methods with ferric ammonium sulphate, ferrion as an indicator. Here oxidation reduction titration with potassium permanganate, there is no indicator. Why? Because potassium permanganate acts as a self indicator. So next we titrated with these CAS and KMNO4. So the assay to be performed in two methods. Then finally the uses for the treatment of anemia. Okay, thank you.